The next packet collection technique for tapping into the wire that we're going to talk about is the use of a network tap. Now, a network tap is probably the most easy to understand form of packet collection because it's literally just a piece of physical hardware operating at layer 1 that sits in between two network devices and intercepts the traffic. So if we had two devices directly connected to each other, we're talking about removing the cable connecting them, putting a tap in between them, and whereas once a cable went from one computer to a switch, it now goes from that computer to a tap, and then from the tap to the switch. So we're literally putting a device in the middle. So when we talk about man in the middle, this is exactly what we're talking about. It's a tap in the middle, very straightforward. Now, there are two types of network taps that you'll encounter. They're called aggregated or non-aggregated taps, and I want to provide an example of each of those with a diagram. First off, we have this concept of the non-aggregated tap. This kind of illustrates the example I just talked about where we have a computer connected to a switch. In this case, for a computer to talk to anybody, it's going through a switch. So by intercepting traffic between a device and the switch, we're actually just going to be seeing everything inbound and outbound from that device, right? So this is how we would selectively target an individual computer with a tap to intercept its traffic. Now, in this case, the computer, whereas it did go directly to the switch, is now going into the tap. We see that marked there with the N line. And then from the tap, we go out to the switch. So the tap's in the middle there. And from that, we have two different monitor ports available. We call them monitor A and monitor B here. A non-aggregated tap basically separates the streams it observes into inbound and outbound traffic. It doesn't aggregate those streams into one port, right? So that's what we mean when we say non-aggregated, is there's an inbound and an outbound port. And then to monitor that, we would connect two cables and plug those both into the sniffer. So in this case, to monitor both inbound and outbound traffic, our sniffer would need two network interfaces that it could connect to monitor A and monitor B. In this case, we'll say monitor A is all inbound traffic and monitor B is all outbound traffic from the tap. So when we say non-aggregated, that's what we're talking about. Non-aggregated taps are usually quite a bit cheaper because they're much simpler devices since they don't have to do the bonding of traffic. So you can acquire these quite cheaply. Now, the other type of tap is an aggregated tap. And really the only difference between a non-aggregated and an aggregated tap is that the aggregated tap actually bonds those that inbound and outbound data stream into one interface. So from your sniffer, you only need a single interface to monitor that traffic. Now, aggregated taps are a little bit easier in that sense. You only need the one port, but a non-aggregated tap is not impossible to use. You can actually bond the inbound and outbound interfaces together via software on your sniffer system so that it looks like a single data stream instead of two data streams. So you're not having to have two capture files for everything you're doing. That isn't a thing that really you have to worry about too much. Nonetheless, aggregated taps are usually a little bit more advanced and can cost a lot more. These are going to be a little more enterprise grade since they're doing that bonding. And oftentimes they'll also have a lot of really nifty software features in there too. Aggregated taps are really designed more for the enterprise approach. So the main use cases for aggregated taps are for continuous monitoring. So we talked about the use case of network security monitoring, where we want to capture packets from an entire segment of our network or our entire network continuously all the time. Well, a aggregated tap is going to be the best solution for that, particularly one with a few advanced features, particularly the ability to fail over cleanly. In a network security monitoring scenario, the way you're going to want to approach that to capture the traffic for an entire network segment is to place your tap between the switch, the core switch of your network and the upstream router. So that basically says you're going to capture everything going to and from your upstream router, which means everything to and from the internet. After all, if a bad guy is going to come into your network across the internet, it's going to come across that link. So that's where you want to capture packets in most cases. It may not be the only place you want to do it, but that's certainly one place you do want to have packet capture enabled from a security perspective. So that's where you're putting your sniffer. And keep in mind, this is a critical link, right? The network cable going between your switch and your core router, if it goes down, then internet goes down for your entire organization or your entire network segment. So an aggregated tap is often going to have, at the enterprise level, it's going to have some type of failover capability where if it dies, communication can still pass. And furthermore, it's often going to have some type of caching capability. So if the network load peaks too high, it will be able to cache some packets, waiting for that peak to kind of go back into a lull and back into normal throughput rate. So taps, again, really designed more for the enterprise approach. They do make cheap ones. You can find non-aggregated taps for as little as $25. There's the ever popular Network Throwing Star non-aggregated tap. You can actually even make your own with a little bit of ingenuity and some Cat5 cables. You can kind of make your own taps, which is pretty neat. Enterprise taps from the aggregated side, significantly more expensive. You're paying more based upon the amount of throughput you need, the advanced features like the failover, the packet caching, things of that nature. Now, network taps are useful, particularly, like I said, in enterprise situations and when you can afford them. I've seen them go enterprise taps for $1,000 all the way up to hundreds of thousands of dollars for really fancy multi-interface fiber optic taps and things of that nature. You can find a tap for pretty much every scenario. They're particularly useful for 24/7 collection. So when you want to collect packets all the time, constantly, these are the devices that are really made for that. And they're also really useful for high throughput scenarios. So when you want to collect packets from multiple systems, an entire network segment, or an entire network, tap is going to be the best way to do that. You can try to do some of that with a switch, but that doesn't really scale to the levels you would need for an entire network. Switch port mirroring is not really designed for that type of thing. And if you try to do it, you're probably going to run into a lot of issues. So a tap is really the best scenario there. Of course, there are a couple scenarios where a tap isn't the most useful. One of those is if you're on a really tight budget. So if you can't afford a tap, then you can't afford it, right? So maybe you can get by with a non-aggregated tap and do it that way. But if you really can't afford enterprise taps, then maybe you're not going to be able to necessarily do long-term packet collection in the way you need to. So that might be a place you can look for more budget later. Taps are also not the best for simple one-off scenarios because they do require you to physically put the tap in between the device whose device you want to sniff the communication. So oftentimes this means unplugging a device from a switch and putting the tap in line there. That can be a lot of work, especially if you're in a network where you're maybe the only network admin and you're distributed and you have to drive out to places that maybe not the most ideal things. So not the easiest to do there. And oftentimes we also just have systems that can't really support that kind of downtime. If you want to examine an issue with an individual server, but that server cannot go offline, then you're going to have a hard time getting packets via tap because you do have to unplug it from a switch for a moment to plug in that tap. And no matter how quick you think you are, you will drop a lot of packets if you just unplug it quickly and plug it straight into a tap. That won't work super well. You will lose some packets there and maybe break some connections. So don't recommend doing that on your production web servers or production database servers under high load. That said, again, taps great for most situations. Generally, I'm always using taps for security and proactive monitoring situations, and I'm very rarely using them for specific focus problems related to an individual machine or something like that. That's when a port mirror may be a little bit better of a solution. But overall, that's network taps. The third packet collection technique I want to talk to for tapping into the wire is a technique called hubbing out. Now, hubbing out is very similar to the process of using a tap, wherein with a tap, we physically inserted a device between other devices whose traffic we wanted to intercept. Hubbing out is going to be the exact same process, but instead of using a tap, which is designed for that type of thing, we're actually going to use a hub. And the reason for this is very similar to the reason it's related to what we talked about in regards to how hubs work, that they are a hardware broadcast device, a simple packet repeater, which just takes input from one device and blasts it out to every port on the network. So in this case, if we wanted to capture packets from computer A and computer A was just plugged into a switch, we could actually unplug computer A from the switch, plug it into a hub, which our sniffer is also plugged into, and then plug that hub into the switch. So what that's going to do is going to put us in the same broadcast domain as computer A. So everything it sends will be blasted to every port on the switch, every port on the hub, and we just happen to be plugged into that same hub. So we'll be able to intercept all the traffic in that way. So it's very easy, really the same concept kind of as a tap in that regard, and that it gives us the visibility we need. However, I generally don't recommend using this technique. I mention it here because if you ever get into a pinch, it is something that does work. However, it's just really not ideal. Again, hubs are very antiquated. Nobody really makes hubs anymore. They're very slow. You're not going to find one with a lot of, you're not going to find a lot of gigabit hubs or 10 gig hubs lying around. So you're going to be using a lot of, 10 base T hubs and unidirectional communication with collisions. It's just going to be massively slow. You're probably going to drop some packets. With any reasonable throughput at all, it's just not going to work. So I don't really recommend this in most cases. But again, if you do get into a pinch and it's the only method you have, then, well, I guess it's what you have and it's what you have to work with. So that's what you'll use. In terms of finding hubs, there was a time when I used to keep a hub in my bag because this was a technique I used from time to time. Nowadays, if I'm going to, if I really think I need to use the hub, then I've already got a tap with me, so I'm using the tap. But you can find true hubs. Google it. Look on eBay specifically. You can find things that are hubs. Not everything that's listed as a hub is actually a hub. For a while there were a lot of people making switches that they named hubs as a marketing ploy when they were actually switches. So you find that out kind of the hard way when you go to sniff packets and realize you're isolated to your own broadcast domain. But nonetheless, you can find these surplus sales, etc. Again, really recommend investing in a tap. You can get cheaper taps for, the throwing star taps for $25, but you can even get cheaper aggregated taps for a couple $100s now. So if you're going to be doing this with any regularity and you think you need to use a physical hardware device to capture packets, tap is really the way to go as opposed to hubbing out.